Bismillahirrahmanirrahim. Assalamualaikum and hello everyone. Welcome to this video presentation on topic chemical structure and properties of major fatty acid, saturated vs unsaturated. This video is a part of a course Oil and Fat Chemistry and Technology. My name is DINIY ISHQANDAR and today I will be guiding you through the fascinating world of the fatty acid, understanding what are they and how the structure differ and why those differ matter in both food and health. Have you ever noticed that butter stays in solid in the counter, while olive oil remains liquid? This difference is beyond the kitchen. It's all about chemistry. Fatty acid, the building blocks of fat and oil, come in different forms, and their structure control how they behave physically, how they affect our health, and how they are used in various food and industrial products. In this presentation, we will deep dive into the structure of saturated and unsaturated fatty acid, compare their properties and understand their significance in daily life.
Assalamualaikum warahmatullahi wabarakatuh. My name is AHMAD ROSRI from ISHQANDAR. Today I will present about what are fatty acid. Let's begin with the basic. So, fatty acid are long hydrocarbon chain with carboxylic acid group at one end. Their general formula is RCOOH, where R represents the hydrocarbon tail. These molecules are amphipathic, meaning they have both hydrophilic and hydrophobic parts. The carboxyl group is polar and water attracting, while the long carbon chain is non-polar and repels water. Based on the presence of double bonds in the carbon chain, fatty acid can be classified as saturated, monosaturated, or polyunsaturated. This structure variation plays a key role in determining the physical state and function of the fat. Then, we continue with saturated fatty acid. Saturated fatty acid have no double bonds in their carbon chain. Every carbon atom is fully saturated with hydrogen atom, resulting in a straight, rigid structure. Because of this straight shape, saturated fatty acid can pack tightly together. This tight molecular packing leads to a higher melting point and a solid state at room temperature. Common examples include palmitic acid, carbon 16, found in palm oil and milk, and the second one, stearic acid, carbon 18, found in animal fat and cocoa butter. These fats are more stable and less prone to oxidation, which is why they are often used in baking and processed food to improve shelf life.
Hi, Assalamualaikum. My name is HAFIY, and right now I'm going to tell about unsaturated fatty acid. On the other hand, unsaturated fatty acid contain one or more carbon double bonds. These double bonds introduce kinks or bands in the fatty acid chain, especially in the cis configuration, which is most common in nature. This kink prevents tight packing of the molecules, resulting in lower melting point and a liquid state at the room temperature. There are two main of unsaturated fatty acid. For the first one is monounsaturated fatty acid, such as oleic acid, which is 18 carbon, which consists of 18 carbons chain and one double bonds. This is an abundance in olive oil. On the other hand, the polyunsaturated fatty acid like linoleic acid and alpha-linolenic acid. For the linolenic acid, there is 18 carbons and there are two double bonds. And for the alpha-linolenic acid, there are 3 carbon bonds in it, while having the same number of carbons. This one is sunflower oil, flaxseeds, and fatty fish. These fats are essential for our health, especially omega-3, omega-6 fatty acids, and omega-6 fatty acids, which the body cannot produce on its own. Now, let's look deeper into unsaturated fats. The arrangement of the atoms around the double bonds affect the fatty acid chains. In cis fatty acids, the hydrogen atoms are on the same side of the double bond, causing a natural bend in the chains. This bend shape contributes to their fluid nature. However, during food processing, especially partial hydrogenation, some cis double bonds are converted into trans configuration. In trans fatty acids, The hydrogen atoms are on opposite side of the double bonds, making the chain straighter, more like a saturated effect. Margarine is a good example. In older formulations, it was made by hydrogenating vegetable oils to make them semi-solid. This process creates trans fats, which are now known to increase the risk of heart disease, and that's why many countries now regulate or ban trans fats in food products. Now let's compare saturated and unsaturated fatty acids side by side. So for the first one is unsaturated fatty acid. Saturated fatty acids contain no double bonds and are straight chains and rigid, packing closely together and solid at the room temperature while having higher melting points. On the other hand, for unsaturated fatty acids, it contains one or more double bonds, having chains of bonds and cannot tightly tied, and liquid at room temperature while having a lower melting point. These structural differences explain why butter is solid while oil remains liquid. The degree of saturation also affects texture, functionality, and how fats behave when cooked.
Last but not least, health and functional implication. The structure of fatty acid not only influence their physical state but also impact human health. Like the first one, saturated fat. When consumed in excess, are linked to increased level of LDL cholesterol, which can raise the risk of heart disease. The second one, unsaturated fat, especially those rich in omega-3 and omega-6, support heart and brain health, reduce inflammation, and are considered essential in our diet. Fortunately, saturated fat are more heat stable and resistant to oxidation, making them useful in frying and baking. Unsaturated fat are healthier but more prone to rancidity, which is why they are often stored in dark bottle or refrigerated. Understanding this rule help food scientists choose the right fat for the right product and help consumers make better dietary choice.
Conclusion, the chemistry of fatty acid play a crucial role in determining their behavior, application, and health impact. Saturated fatty acid is straight, solid, and stable, but should be limited in the diet. Unsaturated fatty acid are bland, liquid, and essential for our health. So whether we are choosing ingredients for cooking, analyzing a food product, or planning a healthy diet, knowing that structural and functional difference between the saturated and unsaturated fatty acid empower us to make an informed decision. So, thank you for watching this presentation.